All right, so the talk today, I'm gonna try to give a presentation of the different services that are available, and also I will try to show you in the console to do hands-on, so that we make it a little bit practical. I'm not sure how it's gonna work, because these demo things live always there is something that fails, but I'll try to make it as practical as possible. Also, I'm gonna be honest with you, I'm not an expert in artificial intelligence at all, so I'm a user of it. I mean, I can use the services that we have available to build applications easily, but if you ask me about the low-level details about how to create neural networks, I have no idea. Okay, so I'm going to start by that. So if any of you probably have more details than me, so it could be a good opportunity, especially later in the drinks, to exchange opinions, and so I think is the purpose of the sessions, this type of sessions. All right, so to start the AWS platform, we have more and more services. At the moment, there are more than 90, but we're going to focus on 4 of them that are related to machine learning and artificial intelligence today. All right. All right, so to give you a little bit of an overview of what we do within Amazon related to machine learning or artificial intelligence, basically we use it quite a lot, but especially in order to improve our internal operations, right? Because at the end of the day, Amazon is a business that is a high volume, low margin business, right? Especially in retail, where the operational excellence is everything, right? So we use artificial intelligence or machine learning in order to improve how we do, for example, logistics. So if you go to our fulfillment centers, you will see some robots moving around that takes whenever someone requests something, instead of the people go to the shelf and look for the item, there is a robot going to the shelf and bringing the item to the people. So we use artificial intelligence especially for this type of things, and actually we believe that the main usage of this is going to be to make operations more efficient. But because we've been using this for probably from the beginning. So for example, this is the website of Amazon.com in 1995, when Amazon was only selling books online. So by then, here you can see the first draft, I will say, of our recommendation engine that you can find in Amazon.com, that based on the type of books that you were buying, and based on the new books that had been released, then it was recommending you that maybe you might be interested in buying this book based on the historic information that we have regarding you. So we've been doing this from 1995, and then it's now that we're trying to expose our capabilities to the rest of the world, so that we can, because our goal or our mission is to democratize the access to this. Because nowadays, in order to get use or get the best of deep learning artificial intelligence, you need to have almost a PhD in statistics, in maths, in things like this. So our goal is to make it easy to everybody to use it, so that people like me, that I have no idea about that, can use it, right? So to give you an overview of some of the projects that Amazon, probably these are the projects that people see about what we do in artificial intelligence. So here, for example, we have all these drones that we are investing and developing in order to deliver items, especially in North America, where people live very spread out, right? So that you can deliver items in less than 30 minutes. Or for example, this is in the app of Amazon.com, that you can put the camera and look into an item, and doing artificial deep learning more or less finds out the item, so that it proposed to buy it on Amazon.com. Maybe you can find a better price. Or for example, Alexa. Who here knows about Alexa? Probably you know. But here Alexa is not yet available in Spain, but this type of artificial assistant, right? that you can ask things and is answering back. But the good thing is that we are making it very open so that people can integrate Alexa with, for example, the lights at home or with your TV, so that using the voice you can control different things, right? You can order a taxi, you can switch off the lights and things like that. For example, Amazon.go is a new project of a new type of shop, so that people go into the shop, take items and leave the shop, and you don't need to go through the cashier. And doing computer vision and some deep learning stuff, we can see what you are taking, and based on that we can put this into your credit card, basically. So these are type of things we are doing. Well, because we don't have a lot of time, I'm not going to put the videos. But not only is Amazon doing this type of things, but other customers of AWS. AWS has more than 1 million active customers nowadays. So a lot of customers are doing machine learning and deep learning on the platform. So for example, this is a presentation of researchers of Stanford that they take, these are images of eyes. And what they do is to try to prevent that people who are developing diabetes become blind, right? By analyzing pictures and taking pictures of your eyes, they can prevent people getting blind because of that. So for example, I put the link there so that you can see the presentation. There is a presentation reInvent and a video available so that you can have a look. Or for example, this is Pinterest. It's a big customer of AWS, and for example, in their app, this is a social network that basically is working especially with pictures, like a little bit. So here, using deep learning, they detect from a picture different items, and also they give you additional information about the different items. They do this in pictures, and they do this, for example, in videos as well. So for example, they take a picture and they can analyze objects that are within the picture. Like for example, here we see that there are shoes, there are like gold, right? So this is the type of things that you can do with deep learning. And it's not that deep learning, the algorithms and all this is very new, because these are all algorithms that have been, they existed since the 50s or the 60s. It's just that nowadays it's possible to do it. And it's possible because the first thing you need is a lot of information. So you need a lot of data, right, in order to train a neural network. And then you need a lot of computation in order to process all this information. So today with cloud, you can store all this information in a cheap way. And also you can leverage all the available computing power that you have, for example, in AWS, and even train your neural network using spot instances. Like you place a bid, maybe you can get a computing power with GPUs or FPGAs with 90% discounts compared to the price on demand. So today you can afford doing that, right? For example, Netflix, or another big customer of AWS, is all in. This is the recommendation engine. Probably you are using, those of you who have Netflix, you are using this every day without noticing it. And some other customers doing, to give you some overview of other customers doing this type of things on AWS. So our mission is to make it easy to everybody to use this. You don't need to be a PhD anymore to use this type of things. So our strategy basically is based on, first of all, we are providing a number of APIs with deep learning models that are already pre-trained with data sets that are property of Amazon.com. And then we are making available for you to consume from an API. And they are very cheap also to consume, so you can leverage those. So the first one is recognition, that is computer vision, so we will see later. So you can upload pictures or videos, and then you can do things like detecting the type of objects that are in a picture, or detecting famous people in pictures, or for example comparing faces, so that you can find out if someone is in a picture or in a video, things like that. The second one is a poly, that is a text-to-speech. Basically, you pass a text and then you can get an MP3 that you can use to get your applications or your machines talking, right? The third one is Lex, that is the brain behind Alexa. It's available for you, so you can use it for natural language understanding, basically to create bots, for example. So you can create bots that you can integrate with chat engines like Facebook Messenger or even with voice. For example, we have a new service that is a call center as a service, right? That is that you can create a call center in the cloud in 5 minutes. And also you can have Lex answering the calls, so that, and Polly talking to the people talking, so that you don't need a person taking the call at all, or at least you can minimize it. And we are working in providing more and more in the half two of the year. The second offering we have is do-it-yourself, basically, because these APIs are very nice, but still there are companies who prefer to create their own models. So for that we provide a platform. So using, for example, the EC2 instances, virtual machines, or for example EMR, where you can deploy Spark with MLib, you can develop your own, you can train your own algorithms. This is interesting. For example, later we will show you, I will try to show you. I'm going to show you here. We provide an AMI. An AMI is a virtual machine template that you can use to launch an EC2 instance in the cloud, right? That is already pre-configured with everything that you need in order to train your own algorithms. So you have all the frameworks available, like TensorFlow, MXNet, Caffe, Theano, Torch. Is already prepared to work with EC2 instances that we have with GPUs. You know, with NVIDIA GPUs, we have a P2 instance that gives you up to 16 GPUs in the cloud. And you have the CUDA drivers, for example, already pre-configured, so that you can run your training, especially for your models on GPUs, in order to speed it up, to accelerate. And this is interesting. For example, we in AWS we like a lot MXNet because it's very scalable. You know, scales almost linearly, no matter on the number of GPUs you have, and also it's very light, so that you can train your model with your data sets in the cloud. And once you have your model trained, you can embed it in your app. And for example, you can put it in an app, in a mobile phone with very little power, or in a Raspberry, and it's already trained in the cloud, right? So we like it. We like it this very much, and that's a reason why people also would like to train their own models, because you can embed these models anywhere. And finally, we provide the underneath platform. So for example, things like S3, that is our object store service that provides you unlimited storage in the cloud, and you pay 0.0023 per gigabyte per month. So you can store, for example, their very big data sets that you might need in order to train your models. All right, so let's go. The first thing I'm going to tell you is what is the difference between deep learning and machine learning, because a lot of people are mixing the concepts. So deep learning is something like, for example, you have this picture on top of it of this dog, and you have another picture, and then you want to make a question like, are these two dogs of the same breed, right? Are they la misma raza? So this type of questions you can only answer using deep learning, because you need a neural network to go very deep, you know, in order to make this to get an answer with a level of probability for that. Whereas machine learning is more like a supervised learning. Based on the information that I have in the past, I can forecast what's going to happen looking into patterns in data that I already have. This is more like what is called supervised learning. So for example, things like, is this email a spam or not? This is type of machine learning, because this is linear regression that is yes or not, you know, but how you come up with to this answer. based on information that you have in the past. So I will show you later. We have a service also that makes very easy to create this type of algorithms. Okay, so the first thing is do it yourself. So the first thing a lot of our customers are using is Spark with mlib, using EMR, that is a managed service. So basically you can have your Zeppelin notebooks with Spark and mlib and create very big clusters in order to train models. But this is especially being used for machine learning, especially. And the second thing is for deep learning. So this is artificial intelligence. So basically, this is a little bit what I said. The challenge of artificial intelligence is the scale, right? Because I need a lot of data in order to train my model. I need a lot of compute. And with that, once I have the model already built, then I can make my predictions. So probably cloud is making this possible nowadays, because before only companies like Amazon or Google's of this world could afford to make this, you know. But nowadays with cloud, everybody can do it. So there's no more barriers anymore. All right, so in order to do artificial intelligence in mode do-it-yourself in AWS, what we provide you is the deep learning AMI that I told you before. EC2 instances, probably you want to use instances with GPUs. We have two models, the G2 family and the P2 family. The P2 family is the biggest one that you can get up to 16 NVIDIA Tesla K80 GPUs interconnected with PCI Express, so you can get a lot of teraflops in order to train your models. Later this year we will bring bigger instances with the new Tesla's V100, so they will be available probably by the end of the year. And also we like MXNet, although we make it easy to use the framework you want. We like MXNet for three reasons. One is you can use any language you want. You can use Python, you can use Java, you can use Scala, the language you feel comfortable. Secondly, it scales very well. So for example, if you want to train a model with a lot of data in a specific period of time, you want a framework that can scale linearly. So we saw that MXNet scales linearly. So that's why we like it very much. And third is very lightweight. So you can embed it anywhere. You can embed it, for example, in a mobile app that later you are going to distribute in your iPhone or Android or whatever. Okay, so this is the type of instances. And also these instances with FPGAs, there are people using them, but these are like FPGAs are like processors that you can program yourself. So you can modify the logic the logic doors of the processor so that you can implement algorithms in hardware. So these are the ones that you want to use for deep learning. So this is an overview of the P2 instance, blah blah blah. F1. Why we like MXNet. And this is the reason we like it, because it's very flexible, you can put it anywhere and it scales very well. So I'm going to show you a P2 instance that I launched with the deep learning AMI, and I will show you a little bit with a Jupyter notebook how you can start playing with MXNet in order to start doing your first models, do it yourself. So let me go to the console. All right. So the first thing I'm going to do is to connect to the AWS console, to the Amazon Web Services console. And basically when you connect here, you see all the services, right? But the ones we are talking today are here, the artificial intelligence, Lex, Poly, recognition, machine learning. These are the ones we are going to be talking today. But here in the do-it-yourself, what I'm going to do is to launch a P2 instance with the deep learning AMI, okay? Actually, I have it already running, but just to show you, you see it's already running, how you can do it. So you can launch a new instance. You will come here to the marketplace and look for deep learning, and then we have at the moment 2 versions, one with Ubuntu and another one with Amazon Linux, and then you can choose the one you want and then you can launch it. Okay, I have one running already with Ubuntu, so this is the one I'm going to show you. Alright, so what I'm gonna do is to launch a Jupyter notebook in this instance. Oh, this is very small, right? Can you see a little bit better? Mm-hmm. I'm not gonna be writing too much, but I'll make it bigger. Okay. Because the Jupyter notebook is running on the instance, I'm going to do a port redirection so that I can connect notebooks. All right. Okay, so once you launch this, you have an instance with all the frameworks already pre-configured. You launch your Jupyter notebook. I like Python, so I use this, but if you want to use any other environment, you can use yourself. And I'm gonna make this bigger. And then I have here 3 notebooks. And the first one is to show you a little bit how MXNet works. It's very simple, really. The syntax is very simple. So you don't need to install the module or the MXNet because it's already installed in the instance. So here, for those of you who are familiar with NumPy, the basics of MXNet is the same as n-dimension arrays, because if you are going to process a picture or a video or a text, at the end of the day, what you are going to do is to create arrays of pixels, right? And this is what you are going to pass to your neural networks and so on. So here, for example, I'm creating an array of two rows and 3 columns, right? And then here I can see the size 6, right? And then I can see the shape, that is 2 lines and 3 columns. And I can see the type, that is float. Also, you can use NumPy, you know. Maybe everybody here is familiar with Python, or okay, never mind, I'm not gonna. So here I'm creating the same, but it's an array that is an integer array, and this is integer. So here I can print my array. You see, and here, for example, what I'm gonna do is to create an array that is the multiplication of my array number 8. You see, so it's as simple as this, you know. And the cool thing here, I'm doing a little bit more complicated, something a little bit more complicated. I'm creating an array, a matrix of 1,000 rows and 1,000 columns, and I'm deploying it in the GPU. So you see, MXNet is very cool because before I was using the CPU, but now I'm starting to use the GPU. It's as simple as this, you know. So for example, when you are training your models, and if you have 16 GPUs available, you can define 16 neurons of your neural network in different GPUs in order to do it in parallel, you know. It's as simple as this, so that's why MXNet is very cool. So for example, here I'm doing quite a big calculation, and it's been done very fast. Okay, so this is to show you that MXNet is quite simple to use. So in this other example, what I'm going to do is that when you are going to do your models, you don't need to reinvent the wheel. So basically, MXNet, for example, by default gives you a lot of models that are already pre-trained with public data sets. So you can leverage those, right? So in this second example, I'm doing this. So for example, this is the MXNet, this is an Apache 2.0 open source project, MXNet. So here you see I have already models already pre-trained, and here I'm going to use a dataset that is ImageNet. ImageNet is a dataset of pictures that is available in the internet. You can download yourself, and actually you can use it in order to process images or videos. For example, you can detect objects within a picture. So instead of taking the dataset and training my model, I'm going to use a model that is already pre-trained. Okay, so basically the one I'm going to use is Inception. So basically what you are going to do is to download two files. You download two files, and then you instantiate your model in MXNet in 4 lines, and then you can use it in order to create your first predictions. Okay, so this is what I have here. So actually the models you can download from here. I'm doing a vget. I'm downloading them locally, and actually in MXNet I'm doing these 4 lines. In 4 lines I'm loading my model so that I can use it later. And then what I'm doing here basically is I take a picture, I create the picture I'm translating in an array of a specific size, and then I'm passing the picture into my model in order to create predictions. Okay, so basically the picture I'm going to use, the first one I'm going to use is this one. For those of you who like heavy metal, this is the Creator singer. So what I'm gonna do you see it's not a lot of lines of code, right? So basically what I'm gonna do is I take the picture, I create 3 matrices of 3 different colors, because this is a picture in colors. One is blue, the other one is red, and the other one is green, right? With these 3 colors you create any combination of colors. Here is where I do the preparation, and this is where I do the prediction. That using the model that I already instantiated, I'm going to do the prediction. So Creator is here. Right. So I think I need to come below. I'm going to check in which directory I am. Okay. Wait, I don't remember the directory. Inception. Okay. All right. So I'm going to run this. All right. So you see it was pretty fast, and what it's telling me is that with 59.88% of probability, there is an electric guitar in my picture. Later is telling me with 26% of probability there is un escenario. So well, the prediction was not very good, right? Well, but I mean, I made a prediction. You see, it's very easy. I download the model, I made a few lines of code, and this model I can put it in my app, in my Raspberry, anywhere. You know, I can embed it. I believe it's 40 megabytes of RAM what I need in order to run this. so it's not more. All right, so I have another picture here that is, this one is gonna be easier. This is our remote control, right? So here I'm gonna change the name of the picture, and you see this one is better. I got with 90% of probability that this is a remote control. All right, so this same thing that we are doing here, do it yourself, right? We have it here in AWS with our service that is called Recognition. So also there is a free tier that you can try for free, and I believe later the price is $1 per 1,000 images processed. So it's not very expensive. So basically here what I'm gonna do is I'm going to upload my the creator singer, and here you see the model is much better, you see, because so I'm getting with 98.8% of probability that there is a person, that there is people, there is a person, there is a human, although it looks as, I don't know what he looks like, and with 97.4% of probability that there is a guitar and a guitarist. So you see, this model is more refined, but this is because Amazon has more information in the model, right? But I mean, you can also get this level of accuracy yourself, but you need a lot of data, to train your model. So if I upload my remote picture, so I get 93.5% of probability that this is a remote control. And actually this is an API. Basically this is a REST API that you can invoke yourself. So actually you can invoke it in two ways. Either you upload the picture like a byte in the request, and then this is the response you are gonna get, right? So you are gonna get the different labels, remote control with the level of probability and so on. Or you can upload your pictures to S3 and then to invoke the service using an API command. So for example, this is what I have here. I'm using the AWS CLI. And maybe this is too small. Oh, wait, I'm in the machine. So you see, you get, I uploaded the picture already to S3, and then you invoke the API. I'm using the CLI, but you can use your code using an SDK in order to get the same, okay? So since I'm showing you already Recognition, so Recognition actually has 5 APIs. So one is to detect objects in a scene. I'm not sure if I have here something better. Okay. The second one is image moderation. So for example, you upload this good picture and it's telling you that with 83.5% of probability this is suggestive. This is in order to do parental control, or in Saudi Arabia they like this. They have the best algorithm in Saudi Arabia, to detect if there is a woman showing something. Facial analysis. For example, this one is going to tell you, for example, it seems that there is a face, there is a female, more or less the age range, so it gives you a lot of information. This one is celebrity recognition, so I want to tell you that, well, that one was easy, right? But for example, we can make it a little bit more difficult. So I'm going to try with, probably you don't know this lady, but she's very famous in Spain. I'm not sure if she's in jail or not, but and it tells you that is Pantoja. So, and actually it's because you see it's using the IMDb database, you know, that is part of Amazon.com. So we're using this data set in order to do this. And actually this is very cool because it tells you where in the picture is the nose, where is the mouth, right? So for example, I have here a stupid app that maybe I can show you. Yeah, that I call it the simple mustache service. This is a serverless app that is using S3, Lambda, an API gateway, and so on, and it's using recognition. So basically, what I do here is that let me see if I am myself here. All right, this is myself. So what I do here is I upload a picture, I invoke a recognition, you know, and then, you know, tells me where is the nose, where is the mouth, so I can put a mustache, right? So you can do this type of stupid things or more useful things like, for example, we have customers like detecting in videos, because a video at the end of the day is a sequence of frames, right? So for example, maybe I cannot show you. A video in every second, probably you have 30 frames. So there are 30 images that you can process almost in real time. You can process them, and you can detect in videos, for example, if someone in an airport is a terrorist, the CIA probably, or in the US, they are doing this type of things, you know. Or for example, if you are a security company and you get a lot of alarms that are being released all the time, maybe you can detect if it is because just the curtain moved or a cat passed and the cameras detected something, or is because there is really a person, you know, breaking into the building or whatever. All right, so so going back to our Jupyter, the third one I have is a third example that is, in the first example, I downloaded a model that is already pre-trained. This example is that I download the data set and I train the model myself, you know. So for this, what I'm using is this data set, MNIST, that is public. You can download yourself. Actually, I'm downloading it from this link. And basically, what you download is this is to detect numbers to detect writing, basically. So it has 60,000 images, the data set, and actually it has, for example, only the 10 numbers, right, from 0 to 9, but written in many different ways, you know, so that no matter how you write, it will detect that this is a 9 or this is a 7 or whatever. So basically, I'm creating different models. You see, creating a neural network is as easy as this. These are 10 lines, you know, that I'm doing this, and actually MXNet already gives an iterator for this dataset because it's very famous, basically. And then training the model is doing this three lines. I mean, you need to know a little bit what you are doing, but it's very simple. I mean, it's not just there's a lot of information available for you to do. And this is where you start training the model. So this is a neural network that there is convolutions and things like that. And then here you see the model, how much the accuracy is learning. So the accuracy is increasing, going from 11 to 12% to 22, 29. So the more GPUs you have, the bigger the neural network you can have, the more parallel you can run it, the less iterations you need in order to train your model. And finally, when you finish training your model, that here you see I'm doing more iterations and I'm getting 91%, 94%. Then you can save it, and then your model that is already pre-trained is 2 files. and these two files, now you can do exactly what I did before in order to instantiate my model. You see, load my model. That now I'm loading the model I already pre-trained myself. And then basically what I did is to write with the paintbrush. I write 10 numbers, myself, in order to show you. Are a little bit small because maybe you cannot see anything. This is a 0 because I put it in 28 pixels multiplied by 28 to not make it very big, so this is the 0, this is the 1, right? So I paint myself with the paintbrush, and then I'm trying here my model. And this is the results I'm getting. So for example, for the 0, it recognized with 100% sure that that was a 0. The same for the 1, the 2, the 3, and for example with the 9 had a 74% of probability because I believe the 9 I wrote it not very well. You see, this is my 9. That so you see it does not recognize very well, but still. So you see. These Jupyter notebooks I will share with you, but it's not here. I downloaded the datasets, but there are plenty of datasets available publicly. Actually, we in AWS we are providing a lot of datasets already for free that you can use for genomics, for different type of information stuff. And actually, this is the key of it. Your datasets, is the key of the intelligence you can do the quality of it. So that's why companies like Amazon or Google are crazy collecting information about other customers as much as possible, because the quality of your datasets is what's gonna make the difference, But nowadays, luckily, there is a lot of datasets available for free. Okay, so I show you recognition. So now I'm going to show you Lex. I'm gonna show you quickly Poly. And Poly basically is text-to-speech, so it supports a lot of languages. Actually supports Welsh. I don't know. I myself I'm from Pamplona, but here there is no Basque. I don't know why. And there is a lot of voices, and basically you pass a text and then it creates an MP3, but it's very fast. The key here is that it makes it very fast and has some intelligence. I'm gonna show you. So for example, here we put it in English.
Hi. My name is Joanna. I will read any text you type here.
All right, so it's a little bit simple, right? But has more intelligence than what it seems. So for example, here, if you say, hi, the stock exchange close at 23%. So for example, I put 23%, right? So it's a symbol that...
Hi, the stock exchange closed at 23%.
So knows how to read this type of things, for example. Or for example, if I put something like this,
He wasn't paying attention. In the middle of the October 3rd, 2014 W3C meeting, he shouted, "Score!" quite loudly.
So for example, here knows how to read the dates properly, but the W3C doesn't know what the hell it is, right? But for that I can do lexicons. So a lexicon basically is that I think I need to show you from... I'm gonna make it bigger. So a lexicon is just a file that you tell him that this means this, So when I tell him to apply the lexicon,
he wasn't paying attention. In the middle of the October 3rd, 2014 World Wide Web Consortium meeting, he shouted, "Score!"
see?
quite loudly.
Now he knows. to read this. But also the lexicons are used also for pronunciation, right? So for example, if you say potato, potato, I don't know how potato, how do you say potatoes in English? Potato. But I don't know, a lot of, in the UK I think they say potato.
Everyone has their unique way.
Potatoes pie is delicious.
Potatoes is in American English. But if we go to English, British.
Potatoes pie is delicious.
Okay, potatoes. But for example, basically here in the lexicon, you can put okay, you can put. Have you seen in all the dictionaries that tells you how things are pronounced with very weird symbols? So you can put it here so that is pronounced properly, right? So I don't know whether I have my potatoes. Okay. Okay. So for example, potatoes is potatoes, but if I put calamari, I mean, but the question is that. You can adapt the pronunciation of every word you want. So it will say calamari, right? And also here SSL, ML. This is very cool because actually this tool is what Amazon used to. Do you know Audible? Audible, these are the audiobooks. Mm-hmm. So this is the tool we use to create audiobooks, right? So here you can do, for example, things like a lot of cool things. Okay, so it's the same, but I'm putting here a tag to wait, for example, 2 seconds, right?
He wasn't paying attention. In the middle of the 10th of March 2014,
this is just to put a pause in between. But this is what you want to do when you are doing an audiobook or where you are developing for example, for subtitles in videos, that you put the same, you put metadata exactly in which moment you need to tell, so that is synchronized with the video. So, well, this is Poly from a high-level perspective, but probably what is the best of Poly is that it's really, really fast. So, for example, as I told you, in the call center we have is Poly who is talking to you because it's really almost real time. So now going to Lex, this is the brain of Alexa and works exactly the same way. At the moment it's only available in the US. I'm gonna make it bigger. I'm going to go back to the slides to show you how these things are made. All right. So, Lex is 2 things: automatic speech recognition and natural language understanding. I'm gonna tell you what is the difference about both of them, but basically it's that either you write or you talk and you say what's the weather forecast, and then Alexa or Lex is a cloud service that lives in AWS, and then what it's gonna do is first of all understand the words, and secondly understand the context to give you an intent, exactly what the hell are you asking or what the hell you want to do, right? This is natural language understanding, is to understand the intent, what you want to say, and then you can program what you want to answer back. So basically when you are going to build a bot, what you need to do is first of all you configure what is your utterance. It's called utterance. That is basically the words that are going to define what is the intent. For example, I want to book a hotel, I would like to book a hotel, what hotels are available, actually it has intelligence because the moment you say hotel already knows what is your intent, no matter what else you say, is quite intelligent. And later, in order to fulfill the action, you need probably more information. You want a hotel, but where? Madrid. Okay, but from when to where to when? I want a hotel in Madrid tomorrow. So this type of questions that you need to ask in order to have all the information you need to fulfill the answer is what is called utterances. So utterances is the question your bot makes, and the slots is the additional variables that you configure in your bot in order to have all the information you need in order to fulfill the request. Okay, so this is basically what you configure, and later Lex works with a Lambda. For those of you who don't know what is Lambda, is the cheapest way of consuming compute in AWS. So basically you upload a piece of code that is a function that receives event computing. So you receive an event with a number of variables in the input, and then you do something and you answer back with a number of parameters in the output. So this is perfect. So Lex works with Lambda. So all your logic, for example, to book the hotel, to call maybe hotel beds, or to call to the payments gateway in order to make the payment, and all this logic is in a Lambda function that also you pay in fractions of 100 milliseconds each time you invoked. So it's also very, very cheap to use Lambda. So I'm gonna try to show you an example of Lex. So here what I have is a bot that is to order flowers. So for example, here actually I created a page in Facebook that I have a flower shop, and then because Lex, for example, integrates with Facebook Messenger, and then someone can chat with me with my page in Messenger, and it's Lex who is having the conversation with you to order flowers, for example. So basically, the utterance I configured in order to invoke to create the intent is something like this. I would like to pick up flowers, I would like to order some flowers, I want flowers. But really, if you say flowers to me, I already know that you want to buy flowers, probably. So, and later I configure some slots because I need to know which type of flowers you want, which day you want the flowers to be delivered, and at what time you want, which day and what day you need the flowers to be delivered, okay? So basically here you can test, actually I'm gonna chat, but also you can test with voice, although it only works with Chrome. So you say, I want flowers, and you see this question that I have here is what I configure here. You see what type of flowers you want, and then depending on, and I say gardenias, and this is my logic. My Lambda function is saying we don't have gardenias. Actually, I don't know what gardenias is, but everybody's ordering roses today. So it's telling me, okay, so I want roses. So which day you want your roses being picked up? And I say tomorrow. So you see, it's intelligent enough so that he knows that tomorrow is the 23rd of June. And what time? I say at noon. So also knows that it's at 12, and then it's ready to fulfill the order. So it's already telling me that this is going to cost $25. You see? So are you okay with it? And I say okay. And then you fulfill the order. This is a Lambda functions, calling APIs or whatever you need to do to fulfill your order. And then you see you can integrate with Slack and Facebook. Although actually you can integrate with API gateway with any chat or any tool that you want. And also you can use with voice, actually, because it's the Alexa brain behind.
How do you provide complex answers with buttons, images and everything?
You could, because actually, for example, with Alexa you can provide images as a response.
Is it something that you do here in this portal, or?
You will do it in your Lambda function. In your Lambda function, in the response, you will make a more complex answer. I mean, the simulator is simple, but the API supports providing more information than only text.
But that's something that you do through the Lambda.
Yeah, exactly. In the response that you configure.
But is there some sort of framework or something that you use to generate those buttons and everything, or do you need to know some JSON? And
yeah, it's
because it depends on the channel.
Yeah, Lambda you do here. So my code is here of the bot, right? But yeah, I mean, you have some templates that you can reuse in order to start. We provide some Lambda functions that you can use to start with it. And later you need to check the API. This you can also code in Python, in Java, in C# or Node.js as well. And the last service I wanted to show you is machine learning, that this is basically supervised learning. This is supervised learning. So this is a service that has been available in AWS for 3 years already. And this is algorithms that are IP property of Amazon.com retail that are available for you to use, basically. So basically how it works is supervised learning. So you need to have information in the past that you use to train your model, because at the end of the day it's a linear regression. So it's going to look for patterns in order to forecast some of the fields, right? So basically what you do is you provide the information in order to train the model. Actually, you can put the information in S3 or in Redshift, that is our data warehouse. So it's integrated also with Redshift. Later you test your model. So typically you have a data set and 70% by default. What it does is 70% is used to train and 30% to evaluate. And then you can adjust the false positives, the false negatives, this type of things of your model. And finally, you make predictions. And actually, it's very cool because once you have the model available, it gives you an API, a unique API that you can use to invoke in real time the model to make real-time predictions. So for example, typical use is that you get a Twitter, you are doing sentiment analysis, and you are retrieving Twitter tweets using, for example, Kinesis of Kafka. And in real time, you are invoking this service in machine learning in order to make real-time predictions of things that are going on in real time. For example, you can do, although you can do it also in batch mode. So you can pass a file, and then it does the predictions for you in batch mode. And actually supports 3 types of models. The first one is binary classification, that basically this is yes or no. So this is fraud or not. Is going to buy this or not, you know. So for example, this type of questions you can answer with this type of binary classification models. For example, will this customer buy this product? Is this email spam or not spam? Is this product a book or a farm animal? Is this review written by a customer or a robot? This type of things, you know. This is a binary classification. The second one is multi-class classification. This is not a yes or no, true or false. This is could be a segmentation. So for example, customer segmentation is you are someone who likes sports, you are someone who likes fashion, you like so it's multiple values, and you can classify things multiple values. So you can say, for example, is this product a book, a movie, or clothing, different categories, or this movie is romantic, comedy, documentary, or a thriller. And the third one is a pure regression model that is to make predictions of numbers, of values. So for example, what is going to be the temperature tomorrow, at what time, how much delay I'm going to get if I take this airline going from Madrid to Lisbon tomorrow, based on the information in the past, right? So this is a regression model. So in order to show you how it works, it's very simple to use also. and also it's very cheap to use. And let me see if I can make it this. Okay, so I had okay, so I had this okay, so I have this data set, right? This is the typical thing that Amazon has about their customers, for example. So this is about restaurants. I have information about restaurants. So for example, I have here that is the age range, the gender, the budget, the price of the restaurant, the type of restaurant, cuisine type, and the rating. And basically, I have information that customers, imagine that you're a website recommending restaurants, like I can't remember the name of this one. So you have this information about your customers, and then you use this to create a model in such a way that if in real time TripAdvisor, so for example, you are TripAdvisor, and you have a user of you looking for a restaurant, and you know that you are someone between 35 or 49, you are a female, typically the type of restaurants you go is under 20 euros. You don't go to, or you are looking for a restaurant that is under 20 euros, not very expensive. And then the price, okay, so I have less than 20 euros and I'm looking for a restaurant that is between 20 and 30 euros, and this is the type of restaurant. And then in the past, people with this in this occasion said that the restaurant was very good. So this way you can recommend the type of restaurant that someone who is looking for a restaurant around in the city, for example, you are not from here and you're looking for a restaurant around here, you can recommend the one he would like the most. So basically what you do here in the service, I uploaded this file to an S3 bucket, right? I have the model already done, right? But basically what you will do is first you will create a data source. You will say where is the file, if it is in an S3 bucket or it is in here. I believe I put yeah, so this is where is my file, and basically it loads the file, and it will start creating the model, training the model. Okay, so basically later what you do is it's going to retrieve the file, it's going to analyze the file. Okay. You see, and already detects what are the fields that are in the file. So, for example, age. And here you can say if it is a number, if it is a category, if it is a text, and also here you will say on which field you are going to make predictions. You know. So I think say continue. Do you plan to use to do a data model? Yes. Select the row containing the value you want to predict. So what I did is to predict the rating, right? And with this, it also is going to understand that I want to predict a field that is categorical, and is going to also know what is the algorithm that needs to apply for this. No, you. So you see it's going to do multi-class classification, because could be excellent, could be very bad, could be good, you know, it's the different values. So with that, takes a while to create the model, and once you have the model available, You can do evaluations in order to tweak the model to make a more false positive, more false negatives, and so on. And once you have the model here, okay, so you can do batch predictions or you can do real-time predictions. So in order to do real-time predictions, I created this endpoint that is unique. So you can consume your model using this endpoint. And then here is just to try. If you want to test how it works, so for example, I'm going to take this line. So it's someone between 20 and 34. That is a female that is between 20 and 30, is looking for a restaurant under 20, and is looking for an American restaurant. So with that, you see this is the request. No, this is the response. So it tells you that this is going to be excellent, an excellent recommendation to make. But if, for example, instead of American, you say, I don't know, continental, this is also we like, and it is seafood. So like, as long as it is cheap, maybe I'm going to look for an expensive one. 20. What is a little bit more expensive? Okay, seafood from select. A ver, bars and puff. Oh, it selects everything. But I mean, you see I mean, it's not always excellent, but it's very easy to make this type of linear regressions to do predictions, you know, based on supervised learning with this service. It's very cheap also. So basically that's it. It's 8:15. So do you have any questions, or maybe we can exchange, we can talk with a beer? Or do you have any question now that you want to make, or any comment? So we go for a beer. All right, okay, muchas gracias.